Alright, welcome everybody. So I'm presenting this video during fourth period today, and so this is actually being live streamed at the same time as I'm recording this. So sorry, second and fifth period, but you don't get to be in part of the experiment. It's just fourth period that gets to see what's going on behind the scenes. So let's start looking at the last part of our lesson of Unit 4, which is going to be solving trigonometric functions using the inverse function. So here are your learning objectives in this lesson. We've got inverse function to solve trig problems. We're going to write a complete solution set for a trigonometric problem, and then we're going to solve sinusoidal modeling problems with what we've learned from those. So those are our three learning objectives. Without further ado, let's dive into the first one. It's how do we solve general trig problems with the inverse function? Okay, so we're looking at what are all the angles that would satisfy that equation, cosine theta equals x, where x is any number. We're trying to solve this equation, and we want to get numeric values for theta. So what I'm saying is like decimal approximations with a calculator. We're going to use a calculator in the inverse function to do this. And I'm going to give you what the answers look like, and then I'll try to motivate why these answers look that way by looking at the unit circle. Okay? So here are the ways that these solutions appear based off the unit circle. All the angles that satisfy this equation are going to look like cosine inverse of x plus a multiple of 2 pi. That's what this 2 pi n means. So this means any multiple of 2 pi. Multiple. So 2 pi n means you can just add another period and you're back to where you started. So that angle would satisfy this equation, cos inverse of x plus a multiple of 2 pi. And then the other one is negative cos inverse of x plus a multiple of 2 pi. Okay? So we've got kind of two different answers, and then all the ones that come out from periods. Cos inverse of x is one answer, negative cos inverse of x is the other answer. There's a more succinct way to say this, and that would be to say that theta that solves this equation is going to be either plus cos inverse of x plus a multiple of 2 pi or minus cosine inverse of x plus a multiple of 2 pi. So plus or minus cos inverse of x plus 2 pi n gives us all the answers. Okay? Okay, so I'm going to show you the reason for why these two answers appear, and then why those extra multiples show up, why we can have those extra 2 pi n multiples. All right, so I'm going to sketch the unit circle. And what we're trying to find are angles that satisfy cosine equals x, where x is some number. X is allowed to be any number from 1 to -1. And as we saw from that solution set, there's an infinite number of angles because we can always just keep going around the circle. So we can always go around the circle another revolution and you'd be back to another answer. So I'll show you what this looks like for a particular answer. Say we're looking for when is cosine theta equal to 0.3. And we'd need a calculator to actually find this answer or to approximate it. But we can sketch the angles that would satisfy this. I need my x-coordinate to be 0.3, so that's going to be around here. That's about 0.3. And so the two angles we see are in quadrant 1, and there's similarly, that's 1 point, whose x is 0.3. The other answer is in quadrant 4. This also has an x of 0.3. And so we can see why the plus or minus answers pop out. This angle is cosine inverse 0.3. And then the one down here is negative cosine inverse 0.3. Okay? And so either of those two angles will satisfy this equation. Cosine inverse 0.3 satisfies it. Negative cosine inverse 0.3 satisfies it. And we could keep going around the circle and find coterminal angles to these two. So if we want to actually get approximations for these, we need to get out a calculator. I'm going to pop open Google Calculator because it's a quick way to find answers if you're working on a computer. So if I go to Google, oh, things got very bright. Let's go ahead and type in calculator into Google. And what we want to do is do the inverse cosine. Why won't this work? Cosine, there we go. 0.3. And that gives me an answer. It's about 1.266. So I'm going to write that answer down. This is about 1.266. And then the negative of that. So that's roughly negative 1.266. So if we want to describe all the possible answers, all the possible angles that satisfy this equation right here, then they would be theta equals plus or minus 1.266 plus any multiple of 2 pi. Okay? So the angles that satisfy that equation, there's an infinite number of those angles. They come from one of those two angles, either positive 1.266 or negative 1.266, and then any coterminal angle to those. All right, we're going to look at the graph and see these answers pop out from the graph, okay? So going back to Desmos, let's use Desmos this time instead of Google Calculator. We're going to graph cosine of x, and then a horizontal line at, what is it, 0.3. So cosine x, equation y equals cosine of x, and then a horizontal line at 0.3. Every intersection point represents an angle where the cosine is equal to 0.3. So every intersection, we've got an intersection here, an intersection here, intersection here. What I love about Desmos is you can just click on the graph and it gives you intersection points. And from the graph, we can see those two answers pop out immediately, the ones that we were talking about before. 1.266 is right here, and the negative of it is right there. And then how might we get this angle over here? Feel free to. How might I get this answer over at 5.017? To which one? To this one or to this one? So if I took this one and added 2 pi, you think I would get here? So these two answers, I'll keep them highlighted, are the two that we wrote down. How could I get this answer that's at 5.017 from one of these two answers? To the negative one. So this one is coterminal to this guy, okay? So the negative 1.266, if I add 2 pi, I get over here. And if I want this answer, who am I coterminal with? 1.266. So to see that, we're just going to calculate. I'm going to take my negative answer. So if I make this negative, oh, this won't, there. And then I add on 2 times pi, I get 5.017, right? That's this result right here. And if I were to take the other answer, which was 1.266, and add on 2 times pi, I'm going to get 7.549, which is that answer over there. And we zoom out, and we see, look, it goes on forever. And so each one of these other solutions is just another multiple of 2 pi later. Okay? So these two generate all of the other ones. Okay. So is this the same case for solving sine theta? So sine theta equals y is similar in that you'll again have an infinite number of answers. The solutions, though, look a little bit different. We have, again, the positive inverse sine as an answer. So sine inverse of y and its coterminal angles is an answer. But then the other possible answer is the supplement to that first one. And that's pi minus sine inverse of y plus any multiple of 2 pi. And from the unit circle, we can see where these two sets of answers come from. Sketching out the unit circle, this first answer, sine inverse of y, is going to be, if I have my y be a positive number, let's pick a y for this. Let's say sine theta is equal to 0.3, just like we did for cosine theta. We're looking for angles where the sine is 0.3. So what does that look like? That's going to be a y coordinate of 0.3 this time. And can anybody tell me what quadrants the answers will be in? 1 and 2 will be the angles where the sine is 0.3. So it'll be right here and right here, roughly. Okay, it's just a sketch. So this has a y value of 0.3. This guy also has a y value of 0.3. So if we draw our angles, we can see one answer pop out right away. This is the inverse sine of 0.3. And then how might I find, I'm going to use another color to denote this, how might I find this angle, which is in quadrant 2, based off of my first answer? It's the supplement. So the green angle is pi minus inverse sine of 0.3. Okay? And so those two answers, the one in quadrant 1 and the one in quadrant 2, then generate all of the other ones, because we just add on multiples of 2 pi again. So my first answer is in red. That's this angle. My second answer is in green. Okay. And the same would be true if we went into negative land. If our y was negative, we'd also have the supplement be over in quadrant 3. Our answers would be in quadrants 3 and 4. Okay. And I'll just to show you, let's compute these so we get ideas for these answers. If we were to do inverse sine, I'm going to clear this, inverse sine of 0.3, we get 0.304. And if I graph sine of x, and we see the 0.304 answer is right there, 0.305. 0.305 is the rounded version of it. To get the other answer, I'm going to take pi and subtract this. So we'll say pi minus that answer to find the other angle, which is 2.837. 2.837, if I look on my graph, is right there. So we have 0.305 as the inverse sine answer, and then its supplement, which is right here at 2.837. And then how do I get this answer right here at 6.588? So that one is coterminal to 0.305. And then how do I get this answer? That's 9.12. That's 2 pi more than this one, exactly. Very nice. And so we can keep going if we want to, but this is enough to see. Okay. Lastly, let's look at solutions to tan theta. It's our last one. Tan theta is simpler, thankfully. Tan theta, the angles are just going to be inverse tangents plus any multiple of pi. So we'll see why this is the case. But inverse tangent gives us the generating answer, and then tangent repeats every pi, so we just need to add on pi to get the next one. So let's draw the unit circle to see why this is true. So let's pick a random slope. Someone give me a slope. Any slope. 3? 3/4. 3/4. Interesting. Okay. We're interested in finding an angle where the slope is 3/4. There's actually going to be many answers to this. I'll use red. Okay, so a slope of 3/4, if we want to sketch this, remember a slope of 1 is, I'll just sketch in a slope of 1. That's along the line y equals x. That's a slope of 1. That's not a slope of 3/4. I want 3/4, which is a little less than this, so that's going to be something like this. So, again, just a sketch. This angle is the inverse tangent of 3/4, right there. I tell you that there's another answer on the unit circle. There's another angle. Can anybody tell me what quadrant the other angle might be in that has the same slope? Not quadrant 2, but in fact quadrant 3, because we need the slope to be positive as well. And so if I were to extend this line over here, we'd have the same slope, and we'd be in quadrant 3. To get to this answer, I would take my first answer and add pi. So this is tan inverse of 3/4 plus pi. I add pi to my answer, and that gets me to the one in quadrant 3, because it's adding 180 degrees. To get back to the first answer, I add what? Pi again. To get to the second answer, I add pi. To get to the... So we can see that we just need to keep going around by multiples of pi, and we'll get back to one of these two answers. So tan inverse 3/4 gives me the first one. I just need to add any multiple of pi, and I get another answer. Again, let's put this in the calculator and see that it matches our intuition from the graph. So inverse tangent of 0.75, that's 3/4. That's 0.643. So if we go back, this is approximately 0.64, what was it, 0.644, if we round it correctly. And so if we were to take this answer and add pi to it, we would be over here. So let's see what that is. Add pi. 3.785. So this is 3.785. Okay, that's that angle. So all the answers would be 0.644 plus a multiple of pi. That's pi. Any multiple of pi will do. To see this again graphically, it's always good to be able to graph to check our answers. We'll do tan x, and we're looking at when is it equal to 0.75. There's our first answer, 0.644 that we calculated. And then that's the next answer in quadrant 3, 3.785. And all these other answers are separated by some multiple of pi from 0.644. Okay? So you can think of this one 0.644 as the root of all the answers. Everything else is a multiple of pi away. Okay? So now we have a numeric way to evaluate these functions. Okay, let's look at an example. Simple example. We just want to find all the x that satisfy cosine x equals -0.6. We've already been doing these kinds of examples. If we plug that into the calculator, we will get plus or minus cosine inverse x. If we just evaluate with the inverse function, we would get x equals roughly 2.214. So I would encourage you to actually get a calculator out, do the inverse cosine of -0.6, and that's what you get. So this is cosine inverse of -0.6. Then you have the negative of that, because remember we get two answers popping out. These answers would be in quadrant quadrant 2 and quadrant 3. Quadrant 2 and 3 would be where these answers are. And then we can just add any multiple of 2 pi onto those. Again, graphically, we would sketch this function cosine. We would look at cosine, and we would plot the line y equals negative 0.6 and look for where they intersect. Oh, it's trying. Really? You know where to go. Too bad. What? Okay, fine. Cosine of x and negative 0.6. So there's the 2.214, there's the negative 2.214, and then we'd have all the answers that are coterminal to those. Plus or minus, plus 2. Okay, slightly trickier. This kind of problem will arise when you're solving your sinusoidal models for a particular value. This has got more steps involved, but fundamentally it's the same task. If we want to find all the x values that satisfy 2 times the sine of pi over 3 times x minus 1 minus 4 equals negative 5.5, this is like saying, what are the times when my height of the spring is negative 5.5 or something like that, okay? We could sketch this to see roughly what it looks like. You'd know the sinusoidal axis, You would know the sinusoidal axis and the amplitude from those values. You would look at this and find the period, and that would give you the phase shift. But we're just going to solve this algebraically. So the first step you want to take is to isolate the sine. It's to get the sine part by itself. And so if I want to get the sine part by itself, I'm going to get rid of what's happening on the outside. Namely, I'm going to add 4 to both sides. That gets me negative 1.5. And then I will divide by 2. And that gets me negative 0.75 for what the sine equals. Okay? Just some simple solving steps to begin with. Now that we have sine isolated, sine of something, you can kind of put just forget about this messy interior for now. That's just something. Sine of something equals negative 0.75. When we do the inverse function, we're going to get an infinite number of answers. We're going to get the first answer inverse sine, negative 0.75. And then we're going to get its supplement. So from earlier, that's the first one. And this one over here is the supplement, pi minus that one. And then we have all the extra ones that arise from adding on periods. So we have all these answers, all these infinite answers that pop out. The first one being sine inverse, the second one being the supplement, pi minus sine inverse, and then multiples of 2 pi and added. On the left-hand side, we have the interior. We have what we have on the inside, what we started with. Pi over 3 times x minus 1. Okay, so next to solve this, we're going to multiply, my next step was to actually put numbers in here so that we have decimals to be working with. The inverse sine of negative 0.75, if you were to calculate it, would be about negative 0.848. And the other one is about 3.99. Okay? So from the unit circle, you should envision your two angles are in quadrants 4 and quadrant 3. That's the negative 0.848 angle. And then this one over here, that's the 3.99 angle. Okay? And then all the multiples of 2 pi after that. To solve for x, we've got to undo everything being done to x. I'm going to use a different color here. So my first step is going to be to multiply by 3 over pi on both sides. And here's where things get a little bit tricky. 3 over pi nicely cancels out that pi over 3. That's the whole point. And the tricky part, distributing 3 over pi through. 3 over pi multiplies this, and you get negative 0.810. That's very close to what it was to begin with. Okay? So 3 over pi times negative 0.848 gets you this number right there. 3 over pi times 2 pi n. Here's where things are a little tricky. 3 over pi times 2 pi n. This effectively changes the period. This changes how often those solutions appear. If I were to simplify this, we are dividing by pi, multiplying by pi, those cancel. So what do we get? 6n as a result. Okay? And so for this particular problem, our period is now 6. We repeat every 6 units of x, whatever that is, time, distance. Distributing the 3 over pi, so that gets us 6n right here. 3 over pi times the other set of solutions gets us 3.810 plus 6n as well. My last step is to do what? What do you think? Add 1. All that does, it does not affect the period. It affects these starting values. So we're adding 1 to 0.810. We're adding 1 to 3.810. Those starting generating values. The period is unaffected by this phase shift. It's still 6. When we add 1 to negative 0.81, we get 0.19. When we add 1 to 3.81, we get 4.81. And so that gets us the 2 answers, and then we have multiples of 6, because that's our period for this function, to get all the other ones. So this would be all the possible x's right here that satisfy that equation. Now let's graph it on Desmos to verify that this actually is what the answer is. And this is a very powerful tool using a graphing calculator to evaluate this as well. So I want you to both be able to do the algebra to solve these equations, and then also use a graphing calculator. The graphing calculator method is, I would say, some ways easier. Okay, so let's go ahead and have this give me an error because for whatever reason it's not liking my links today. I give up. Let's plug it in. Okay, 2 times the sine of pi over 3 times x minus 1 minus 4. And we're interested in when is this equal to negative 5.5. Is that right? Fantastic. So I have my function, my sinusoidal function as. Alright, so I don't know where it stopped recording. Did it just stop recording? Oh, you just saw it. Oh well. We'll find out. So we have 0.19 and 4.81 as those 2 answers that we got earlier from the algebra. So from the calculator in the algebra, we got 0.19 and 4.81. And then we've got all these other answers over here. So if I took 0.19, how do I get this answer? Add 6. How do I get this answer that's 10.81? Add 6 to what? To the other answer, 4.81. How do I get this answer right here? Add 6 to this one. Okay? So you can see that there are many, many answers, and they're all 6 away. Some multiple of 6 away from one of those first 2. Okay? So that is how we solve these kinds of sinusoidal modeling problems. We can do it with a graph, and we can also do it algebraically. Thanks for experimenting, guys.